Thank you so very much for making this time. Today is the third session of Smart City Water Lunch and Learn webinar. Today we're going to talk about comparison of land development modeling in OTTHYMO and SWMM. And specifically, we are going to talk about Visual OTTHYMO and SWMM, the two software that we Smart City Water provide and have for um, the water resources slash civil engineering community. Make sure you have us followed on Twitter and on LinkedIn as well. We will have this webinars continued every other Wednesdays. I'm going to keep everyone updated about the next topics that we're going to have. The next one most probably is going to be about LIDs and how to do LIDs in Visual OTTHYMO. We're going to cover all 8 uh, features for LIDs in next sessions. So without further conversation from me, I'm going to open my presentation and just letting you guys know, feel free to chat or ask any question that you guys have on the chat of the session, and I will go through it and follow up with that one and address those questions if we have time. So I'm going to start my presentation with thanking everyone that make this time. Welcome to Smart City Water. I am Jason Mahmoudi. I'm technical specialist at Smart City Water. I started in Smart City Water around 7 months ago, and I'm really glad that I did and I made that decision. I got my master's in 2019 from University of Western Ontario, and ever since I started working as a climate scientist and water resource engineer, I moved to Nova Scotia. I was working in a consulting firm, and I moved back to Ontario and started working for Smart City Water as technical specialist on both Visual OTTHYMO and SWMM. And today, what we are going to talk about is the land development. And as you guys know, most of the consulting firm, different sectors, government, as well as municipalities, conservation authorities, and uh, again, consulting firm, and even sometimes universities, they are involved with lots of developments that is happening. And as you guys know, we need to have and we need to follow and meet some requirements from design criteria of any legislation that is coming out. And just a heads up, right before this meeting, the first session of the webinars of MECP was happening about the new CLI legislation that is confirmed is out. So you guys feel free to join those webinars as well, which is very informative about the new legislation for any subdivision and any sanitary sewer designs. So what we want to talk about here today is I'm going to talk about the differences between Visual OTTHYMO and SWMM. So technically the OTTHYMO engine and SWMM engine, and what are the applications of those. Most of you have already worked with OTTHYMO before. Visual OTTHYMO is also one of the most advanced OTTHYMO engine software in the market right now, very well established in Ontario. It's basically and technically for watershed management, for planning level, for rural watersheds, for the watersheds that we don't have that much information about. We don't have that much detailed information. Visual OTTHYMO is amazing in order to give the most and the best results possible. So it is very well established. The interface is very well known. We do have LIDs features already embedded in the software, so we can use them. We do have different types of watershed and hydrographs like the Nash height, stand height, and etc. And both the schematic and the map view is very intuitive to use, so you can easily just drag and drop them and then connect them with each other. And in the schematic view, you easily can make a very nice conceptual model. If you want to understand the connection between the different parameters or different parts of your model, you easily can use the schematic. And if you want to have a better understanding and better visualization of what is going on in the area, you can use also the map view of Visual-OTTHYMO. However, when we go to subdivisions, when we have more information about our watershed or about our catchment, or when it comes to sewer design, both sanitary, storm, or even combined sewer design, we need a like a stormwater management modeling, or SWMM, or in other way, swim engine software, which there are a lot of them outside in the market. And then we also came up with VO-SWMM, or swim engine software, which I'm going to focus on today. By the way, before this meeting, when I sent you the link of the meeting, I already sent the license file for both Visual-OTTHYMO and VO-SWMM. So if you are our client, so if you have these licenses on your own, you can feel free to use it and work on it and practice it on your own. And if you don't have it, feel free to use those licenses and then start working and practicing with it. It's going to be expired on June 11th. So you will have 3 days to work on it on your own. So VO-SWMM, exactly like Visual-OTTHYMO, are completely based on Ontario legislation. This is one of the advantages of VO-SWMM and Visual-OTTHYMO for our clients, because they don't have to worry about the new legislation. For instance, the new ECA-CLI legislation requires a lot of manhole INI analysis, manhole inflow and infiltration analysis, which we're going to have a session of the webinar specifically about manhole INI analysis and how to model our manholes and how to locate vulnerable manholes. We're going to talk about that one in one of the sessions. But we do have that one, manhole INI analysis, already embedded in the software in VO-SWMM. Most of the time, we confuse about Visual-OTTHYMO and VO-SWMM. Visual-OTTHYMO is only a hydrologic model, and VO-SWMM is both hydrologic and hydraulic model. So we can do a land development with VO-SWMM as well, which today's focus is mostly on VO-SWMM. In order to talk and to actually see how we can do a land development with VO-SWMM, I actually came up with an example that we want to follow with each other and go and do it on actual software on VO-SWMM, both to see the interface of VO-SWMM and also to be on the same page of how we can do that land development on VO-SWMM. So the pre-development condition of our example for this session of the webinar is we have a 29-acre natural catchment area. So that area is primarily pasture land, and the type of the soil is silt loam soil type. But what we plan for it is we want to have new residential development for the entire catchment area of ours, except one part, which is going to be the parkland, which we will talk about it. So this is the background image that we have from our catchment area. And also we do have some information about our catchment area in the pre-development condition. The area is 28.94 acre. The width of our catchment is 21 feet. Again, width of the catchments, there's always debates. It's very controversial and very controversial. So one of the most common way of calculating the width of catchments in any swim engine software or any modeling, what we do is we technically we calculate the longest overland flow, the length of that, the longest one, and we divide the area by the length of that longest overland flow, and we come up with the width of our subcatchments or our catchments. We do have the slope of our pre-development condition and the imperviousness, the roughness coefficients of both impervious and pervious area, the depression storage for both impervious and pervious, and the maximum infiltration rate, as well as the minimum one with the infiltration decay coefficient. So we do have all of these information, and also now we want to know how we do want the report to be. So the analysis option of our modeling. So we want our modeling with the US customary unit, which is so cubic feet per second. The routing method, we want it with the kinematic wave. We do have the start reporting time and date. The start analysis is not important for a single event because we want to focus on one specific return period. For this example, I want to use three different return periods, 2, 5, and 100, or 5, 25, and 100. And what we care about is the reporting time and date. So we want to know that when we start reporting and then when we end the analysis. And the time steps of our report, we want it to be 1 minute because we want it to be very temporally high resolution, as well as the routing time steps. We wanted also 1 minute. We can't have, let's say, 5 minutes routing steps and we want the report to be 1 minute because it doesn't make sense. The routing time steps should not be more than the reporting time steps. So this is also our analysis options for the pre-development as well as the post-development. Excuse me. And also for the post-development, what we plan to have is, so the first question is, do we have any topography changes? Not really. The only topography change that we're going to have is for the parkland that we design to have in the future. And so consequently, the streets will follow the natural slope. The residential lots will be graded by 2% because we want the slope to be right directly toward the street, and then the street will collect the water and then get it out of the city. And where's the outlet of the catchment? The outlet of the catchment is going through a stream, through a culvert at the southeast of our site. So this is a post-development catchment of ours and what we're planning to have. And then with the red circle, I highlighted what is going to that culvert that is going to be the outlet of our catchment. So we do have 7 different subcatchments, and I wrote them as S1 until S7, and then the outlet is going to be at the southeast of our site. And in order to better understand what is going to happen with different subcatchments, I came up with this table that shows what is the area of these different subcatchments, the width of them, which we already talked about. One of the ways to calculate the width of, because one of the parameters that we need for any type of modeling is the width of the subcatchment or width of the catchment. And again, one of the way to calculate the width of the subcatchment is to divide the area by the length of the longest overland flow or overland route that we have, and then we will get that this is one of the approaches. And then the slope of different subcatchments, the percentage of imperviousness, and the roughness coefficient of impervious and pervious area, depression storage for both impervious and pervious area. And yeah, so what we want at the end is we want to model both pre-development and post-development. So these are the data that I already have. So what I'm going to do right now is I'm going to open the software and actually get the hands on the software, and then we can go from there. So this is the interface of VOSWIM. You guys already have the license for VOSWIM. So if you want to practice what we're talking about, feel free to ask, and I can give you either the link of the data that I'm proposing and we're practicing, or I can just send you the presentation file and then you can go from there. So what I want to have is I want to make sure that I'm opening a VOSWIMs, because we do have two types of software, OTTHYMO and VOSWIM. Land development using OTTHYMO is very well established, but we do have so many questions and we do have so many inquiries about how to do land development using VOSWIM. So this is the reason that we're actually working with VOSWIM on for this session of the webinar. So one of the licenses that we have is VioDual, which you will have access to both Visual-IThymo and VioSwim, because both Visual-IThymo and VioSwim, first of all, are compatible with each other and they work under the same installer. So the license that I already gave to you guys is VioDual. So you will have access to exactly what I do have access to. If we are going to open a new project, we'll see that here we do have new IThymo project and new continuous OTTHYMO projects. So these two are Visual-IThymo. The first one is VO single event. The second one is VO continuous modeling. And then the third one is VO swim, which we currently are using here. So, and again, we do have a schematic and a map view. It depends where exactly you want the map view to be at. So if I want to change my map view, or I want to make sure where exactly I am at, all I need to do is I need to go to home ribbon, and then under the option, I want to make sure that I have the schematic view. So if you don't see the schematic view, make sure that you actually go through the general ribbon of the option and make sure that you have the schematic view as yes. And the units are CMS. If you don't want the unit to be CMS, for instance, for this specific webinar, we want to work with CFS, you can change it from here, or you can change it from the properties tab here to change it to CFS. And then I want to make sure that I am in the right GIS, but right now for this session, we want to focus on the schematic part because we want to see how we easily can drag and drop and how we easily can connect different parameters to each other. So what I want to focus right now here is I want to come to the properties tab, make sure that the unit is on CFS, not the CMS, cubic feet per second, and then the link offset is on depth, not the elevation. The reason that I'm just giving a bit of a pause is because some of you guys are following the same approach that I'm doing. So I just want to make sure that we are going with the same pace with each other. So the unit is CFS, link offset depth, and I want to have the background because I do have the background picture. I want to visually better understand what is happening. So make sure that this background is checked. And then we come here to the schematic panel. I want to add the background picture. By right clicking on it, I will come to the background and I click on change background. And so I do have the data for the background. I do have the image for undeveloped site. I just double click on it. And now I can see the background picture of mine. If you want if you want to zoom in, or if you want to better understand or visually see your area, you can actually either hide different parts or just shrink different ribbons around the pages. So this is the background picture that I have. All I need to add is I need to add a subcatchment or a catchment feature to this part as a representative of my catchment and an outlet on the southeast of here. So I will add my subcatchment just by dragging and dropping it here. So this is the representative of my subcatchment, and I can see the subcatchment here on the parameter table that I have one subcatchment. Everything, because I'm using the schematic view, everything is on default. So I need to define different parameters of that. And also we do have an automatic error list or QA/QC here that it tells us before we want to run the model, it tells us if there is anything wrong with our modeling. So it says subcatchment 1, catchment is not connected to a node, which is completely correct because we don't have the outlet yet. So this is the subcatchment that I have. And then just for better understand what is happening, I want to change the name of the Nash height to S1. So the Nash heights are changed to S1. And now I want to go and change the area to the actual area, or the attribution of my subcatchments to the actual values that I have for pre-development condition. So I'm going back to my slide to come up with the numbers that I had. So I don't know if you guys can see my slides. Just going, let me just share my screen because I believe that it is going, let me share the entire screen. It's going to, yeah, there we go. So the actual area was 2894. So 28, oh, this is outlet. The area is by acre, 2894. And then the width is 2521. 2521. The slope is 0.5. So I will have my slope as 0.5, which is already correct. The impervious area is 5%. Imperviousness area is 5%. And then the roughness for the impervious and the pervious is 0.015 and 0.24 for the pervious area. So pervious area is 0.24 and this is 15. I'm just going to change them. And depression storage impervious is 0.3 inch, 0.3. The percent of zero impervious, oh, there we go. Oh, I just want to make sure the 25% was correct. And then it's going to be routed to the outlet. I'm just going to make sure that I'm following the same approach for the catchment area. So the infiltration rate, the method is the Horton method. I just want to make sure that I have all the max infiltration rate correct. So the maximum infiltration rate is 4.5. 4.5 is the maximum, and the minimum is 0.2. 0.2. The decay constant is 6.5. So 6.5 also for the decay constant. I will press OK. So this is my subcatchments. Everything is done for the subcatchments of mine, and all I need to do is adding an outlet. So I just drag and drop the outlet here, and all I need is just to connect my subcatchment to the outlet. I easily go and do that. I just want to zoom in to make sure I'm in the right spot. So the outlet, I just have to make sure that the outlet of mine, oh, I'm sorry, I think I came out of it. There we go. So I just want to make sure that the outlet value of mine is, so the invert value should be exactly at the value that the outlet of the catchment is. I'm going to write down the value was 4962. 4962. Oh, that's the invert value, the geometry. 4962 is the invert elevation for the outlet of mine. And Now my model is ready. So this is only the pre-development. The pre-development, we had almost entire place as the pasture land, and we just want to connect that to the outlet. So all I need to do right now is I need to add my rainfall data. In order to add the rainfall data, I will go to the simulation, to the resource library of mine. So we do have some predefined resource library data already embedded in the software, but for this one, I already have my storm file. If you want, you can follow the IDF curve. If you have the ABC value for the IDF, you can just import the IDF values and it's going to calculate the IDF curves. Or if you have any CSV file that you want to add to the model, you easily can add to the model as well. But for this one specifically, I do have the values for my area. You can get it from Environment Canada. It doesn't matter what type of value you have, but I want to also update my resource library as well. So I would just click on that one top group because I want to I want to create a folder only for this, let's say for this webinar. So I want to add different design storms from multiple storm files. So I will just right click on that one, add new design storm from multiple storm files. I will go to my design storms, and I do have three different ones: 2-year rainfall, 10-year storm rainfall, and 100-year storm rainfall. I will choose all of them and I will open them. All right. So 3 of them are added here. I just want to make sure they are all in the imperial method or the unit, but I want to add all of them to my model. So I will make sure that I add the entire design storms to the project, and I will get this notification that the resource library added all of those 3 storm files that I have to our model. So I will come, so this notification is just asking if you want to save this on your resource library or not. I don't want to save it, so I will just come back. Going back to the project manager, I see here that I have scenario 1 that I want to change the name to, let's say, pre-development. The pre-development of mine, I do have one scenario, and then the rainfall data, I do have these 3 rainfall data for mine. So all I need to do is I need to run the model. But also when I want to run the model, you can do it on the batch. So one of the features that we do have in VO and VO is you can run the entire batch to the model. So before that, I need to make sure that I'm following the kinematic wave as the routing model, and also I also need to make sure that the time steps are the ones that I was looking for. So the time steps, the reporting, I can just put it as 1 hour because it's not that important for us, as 1 minute, I'm sorry. And then the runoff dry weather is not that important for us because it's a single event. And then for the wet weather runoff, I want it to be at 1 minute again. And the routing, I want to make sure that the routing of mine is at 60 seconds or 1 minute. So I just press OK on that one. And then at the end, all I need to do is I need to go and run the model. So I want to run the entire batch. I just click on running and then the batch is complete. So if I want to see the result, I either can come down here to see if, for instance, I just ran the 10-year, but if you want, you can just select all of those ones and then run the entire batch. But I do have the 10-year value for the outfall of mine. If I just click on the outfall, and if I go and plot the result under the simulation tab, this is the depth, I will see the total inflow of my values. For the post development, what we can do is we can easily copy and paste the pre-development scenario. So if you want to copy and paste, if you want to have the same, let's say watershed, and then just continue doing it, all we can do is we can just go to the properties tab or project manager tab, and then click on the pre-development, duplicate it. I want everything to be exactly the same thing. I duplicated it here. So, and I just want to rename this and edit this scenario to be our post-development scenario. So I just changed the name to post-development. So now I want to follow the post-development. I want to change the background because this is not the background for the pre-development anymore. For the background, I will just change the background to the developed side. So this is the background for the developed side. And these are not the values for me anymore. I can just delete them. So what I need to do is I need to copy and paste or bring my watershed for S1 to up till S7 and then put in the outfall here. So S1, I do have 1 as S1, S2, S3, S4, and then I have S5 here, S6, and S7. And I also have an outlet here. I will just put my outlet here. I need to make sure that all of them will be connected to the outlet because they will all follow the natural slope of the catchment. So they will all flow to the outfall of mine. I easily will connect them all together. There we go. 2 more. There we go. And I have 1 in the bottom. Here we go. So all of them have a final node right now. So what I need to do is I need to update my catchment values. So what I have here is my catchments is number 3 to number 9, which is the representative of S1 to S7. The reason that the name is start from 3 is because I already had 2 features, which was outlet number 2 and S number 1. That's why I start from 3. So what I need to do is I need to update this data. I already had the values for that in the table that I was showing you guys beforehand, that the values for the subcatchments, for instance, the area, the outlet, the width, the slope, and etc. So I already created a table. All I need to, so if you want, you can create your table in an Excel file, or you can come here and then change, for instance, the area to whatever the area was. But I created that on an Excel file, and I just copy and paste the table and come here and click on the first one, select the first one, and then just paste it. And I already paste the entire table of mine here. So all of the subcatchments values for my developed condition is already pasted. So all I need to do is I need to make sure that my outlet is also following the same value that it had before. So I will come to the outlet again. So under the properties tab, the outlet of mine, I will just name the outlet as what it used to be. So it was outlet number 2, outfall number 2. And then the invert elevation, again, it's because the invert elevation hasn't been changed. So I just put it as 4962. And all I need to do is I need to go and run the model, because the model, the rainfall data that I have is still going to be the same rainfall data that I had before. So I will just go and run the model. And since we copy and paste, I'm just going to double check. Since we copy and paste the scenario from that one, the engine is going to remain the same thing from the Horton, and then time steps going to be 1 minute for the reporting, 1 minute for routing. The wet weather is still going to be 1 minute. And I just want to make sure that I'm running the model under the same approach. So I will run the model again. So my batch is successfully completed. I do have 2 models run here, as you can see. And what I want to do right now is I want to compare my scenarios. I want to compare different scenarios with each other. So what I have is I have pre-development versus post-development. But what I want to compare with each other is my outfall. And I want to get the total inflow of my outfall. So as we can see here, I'm just going to go for green and red. So my pre-development, we had the pre-development by green, and as we can see, the pre-development, we had it by green. So this is the peak flow of the pre-development, and this is the peak flow for the post-development. So, and as you know, we need to make sure that our post-development peak flow would not exceed from the threshold by the regulations or for the design criteria defined by municipalities or conservation authorities. And then we can control this peak flow by LID or by BMPs or for any flood control practices, which one of them is LID, which we will talk about it next step or in the next session of it. But this is what we got. And then also if we want to export it or if we want to save this for the reporting purposes, we easily can either save it here or we can have the minimum and the maximum of our pre-development versus post-development for the outfall here, or we can have different subcatchments. If you want to compare different subcatchments of one scenario to each other, you can do it. But since different scenarios, the pre-development we had entire one subcatchment and post-development we broke it down to different subcatchments, we won't be able to compare those subcatchments to each other. But for the outfall, we can do it. And also this is for 100 year. If you want, you can compare it with 10 year or 2 year. And then we can compare different, if you also want, you can create another scenario, which is going to be your post-development with a flood control or with LID or with a mitigation, and also bring that one as well on this picture to compare different scenarios and use it in your reporting to send it to the municipality to get approval. Because at the end of the day, what they care about is if the post-development versus pre-development, you're not generating an excess of them. So that was the presentation. At the end, if you want, you can just save the project. I'm just going to save it as webinar number 3. And that was the presentation of mine. So if you guys have any question, feel free to ask. And if not, we can just quickly wrap up the 3rd session. Do you guys have any question by raising hand or feel free to write it in the chat? I will take it as a no. There was a question last week about. Yeah, absolutely. Let me give you, Bill. Let me give you the mic so you can. I believe you can have access to unmute yourself, Bill. Just let me know if, because last week one person could unmute themselves and another person couldn't, so there can be a potential.
Am I there?
Oh,
can
perfect.
You hear me?
Yeah, I can hear you.
All right, sweet. Sorry, I just wanted to catch you there before before you shut it down. Last week there's a question about whether stormwater management ponds could be designed in these programs, and I missed the answer, and I was wondering if you could help answer that question again.
I'm sorry, I was on mute. Yeah, absolutely. Alicia, do you want to answer that question?
So I mean, you are asking like a question like 2 weeks ago, right, for the webinar, and I think we mentioned that the pond design tool will be released in this month. So the pond design, right? So right now what people can do, they can put a rating curve, and they can, it depends which software you use. If you use OTTHYMO, so you can give the rating curve. Basically, that's a discharge, discharge in relationship with the volume. So that's a rating curve. But right now we're working on something, so you can define the shape. So you can define if it's a pyramid, it's different shape, and give the dimensions. And then you can design the discharge by the orifice or wheel. That's in OTTHYMO. But for the swim part, the wheel swim part, it's quite simple, straightforward. So everything is there, so you can design the pond by its dimensions. That's in the, it's also coming in the new release. And also you can define the discharge by orifice, by rating curve, by wheel. So basically you can do both in both OTTHYMO and the swim. But the thing that I think people may be interested is about the pond sizing tools. Basically, it will size the pond automatically based on your existing and your target. So that's one thing that we're working on now, and also it will be released in this month.
Okay, awesome. Thank you so much. That totally answers the question. Thank you very much.
All right, welcome.
Okay. Is there any other question? All right. Um, I assume there is no other question. I want to thank you guys for staying with us, and thank you for following our webinars. I am going to inform you guys about the next session of the webinar. Again, we try to input or add one session or allocate one session of our webinar specifically for ECA CLI, the new legislation. We're trying to work on it to come up with the best content possible, most accurate and most efficient one. I'll keep you guys posted about that one. And for the next episodes or next sessions of the webinars, so you may want to follow us on LinkedIn or on Twitter, or I'm going to also email out about the next session and then the registration form. Thank you so very much. That was the third session of Smart City Water webinars, and we talked about the comparison of land development modeling in OTTHYMO and SWMM, and we did an example in SWMM model, VO-SWMM, and we'll see you guys in the future. Thank you so very much, and have a great rest of the week. Cheers.
Thank you, Jason. Thank you. Have a great day, everyone.